In this video, we will learn how to solve a first-order differential equation with the initial condition numerically. Okay, we'll consider to solve this problem. I'll use t here. You can either use t or x, doesn't matter. Okay, and we know the initial condition. In this whole chapter, we try to solve this equation 1. Very few equations like this, first-order differential equation, we do know how to solve exactly, such as linear equations, separable equations, or exact equations. Unfortunately, the most differential equation like equation 1, we do not know how to solve them. So what should we do? We should solve them numerically or approximately. Okay, so as we know, the solution of the differential equation is a function like this. The graph of that is a curve. So here's a t, here's a y. So say here's a t0 and here's a y0. So the solution is a curve. Okay, so this is a solution, is a curve. We don't know how to solve them. So first of all, let me tell you what is a numerical solution looks like. What do we expect to get numerically? Okay. So they are like this. We don't know this curve. Okay. So numerical solution will give us the approximation. We know this point on the curve. Okay, that's our initial point. 1t equal to 0, y equal to 0. We don't know the other points. Okay. Numerical solution will give you approximation of your true solution at some given points. Say this point is a t1, this point is a t2, and a t3, and so on and so forth. So numerical solution will give you approximation of your true solution at t1, t2, t3, and so on and so forth. Okay, that's what we expect. Alright, now let's see how do we find them. Now, what do we know? Okay. First of all, we don't know this curve, but we do know a point on this curve. This point is t0, y0. It's our initial condition. Okay. And we also know this. We also know the slope. Okay. We know the slope. Okay. What is that slope? Look at this equation. What is that equation rate? This equation rate, y prime, like say t0 equal to, you just replace t by t0, then you got y0, okay? Because y is a function of t. 1t equal to t0, then y of t0 give you y0, okay? So therefore, if you give us a differential equation, you give us f, you plug in, you find your f t0 y0, which is y prime t0, which give you the slope. So we do know the slope. So then we can make this tangent line. This tangent line will give you good approximation to this curve. Okay, the difference between those points we call the h, okay? They're evenly spaced. In the other words, your t1 can be defined by t0 plus h, and your t2 can be defined by t1 plus h, okay, and so on and so forth. So when h is small, this tangent line will give you good approximation. Okay. So we don't know. Okay, this point is y evaluated at t1. We don't know that. However, we can use this value to replace that. We give this point, we say at this point is t1, right? And we don't know this. We call this point is y1. Okay. So this point is t1, y1. Now, what kind of equation t1, y1 will satisfy? Now, this is on this tangent line, right? So you got 2 points, 1 point here, 1 point there. If I do y1 minus y0 over t1 minus t0, they should give us the slope, right? Slope of a tangent line, which is this one, which is y prime t0. At the same time, it's equal to ft0, y0. Okay. So now let's solve this one to find y1, right? That's what we want to find. y1 here give you approximation of y evaluate at t1. Okay. So now let's find y1. So you can solve for y1 is equal to y0 plus t1 minus t0. Okay, t1 minus t0 is h. Okay. So we can easily, we know y0. Okay, we know h, we know t0, y0, we can find it. So we can find y1. Okay. What is y1? So to find y1, you need to know what y1 means. y1 would give you approximation of y evaluate at t1. Okay. And we can keep doing this. Find y2, and so on and so forth. Okay. So in general, if you give us, for giving t0, y0, we can find y1 and y2. In general, we can find yn. yn plus 1 is equal to yn plus h, fxn, and ftn, yn. So let n equal to 0, you find y1. Let n equal to 1, you find y2. And so on and so forth. So this sense, if you use this formula, you find a whole bunch of y's. Okay. So this is what we call the Eulers method. So by doing this, you start with y0, okay, then you find y1. Okay. What is y1? y1, you need to understand. You can find a bunch of y's, but you need to know what are they. Okay. y1 give you approximation of y evaluate at t1. Then you can find y2, which is approximate of y evaluate at t2, and so on and so forth. So after you do the Eulers method, we can find a bunch of y there. They give you approximation of your true solution at a given point. Okay. So this is the Eulers method. Okay, now let's look at the example. How do we use Eulers method to solve a differential equation? Let's solve this one. Y prime equal to 3 minus 2t minus 0.5 y. Okay. And y0, t equal to 0, y equal to 1. Okay, now, so this is a special case of equation 1. Now, first order differential equation. Now, do we know how to solve this one exactly? Only 3 types of equations we do know how to solve. In fact, this equation is linear. Okay. For solve linear equation, you have to write in this form. Remember, then this we call the P, this we call G. Okay. Use the formula we learned before, we can find the Y. Okay. Y there, we can solve exactly. 14 minus, I'm not going to solve that here. Okay. 4t minus 13 e to the minus t over 2. Okay. This one we do know how to solve exactly. Okay, now, if I want to find 1t equal to 0.2, for example, we want to find this. If you know exact solution, find y evaluate at t equal to 0.2. It's easy, right? You just need to replace t by 0.2. you can find that is 1.43711. Okay, now let's assuming we don't know the exact solution. Okay, we still want to find this. Y 0.2 is equal to what? Approximate equal to what? Okay, we want to find that. Assuming we don't know the exact solution, okay, because most of the equations we do not know how to solve it. Okay. Now let's use Eulers formula to do it. Okay. So what do we do know? We know T0 here is 0, right? Y0 is 1. Okay, now we want to find this. Okay. Now we want to use Eulers formula. Okay, Eulers formula is like this: yn plus 1 equal to yn plus h ftn yn. Okay, so if you want to use this formula, we need to know the h. Okay. Now let's solve this problem in 2 or 3 ways. First, let h, we chose h equal to 0.2. Okay. So our t1 equal to t0 plus h, right? t0 is 0, h is 0.2. So our t1 is 0.2. Okay. Now let's find y1 first. y1 here is equal to y0 plus h ft0 y0. Okay. Now let's find what is ft0 y0 first. Okay, let me put it here. Okay, ftx ty from the previous page equal to 3 minus 2t minus 0.5t. That's my fty. Okay. So what is ft0 y0? I mean y0. t0 we said is 0, y0 is 1. Okay. So in this formula, whenever you see t replaced by 0, here's a y here, sorry. If you see y there replaced by 1, so you got a 3 minus 2 times 0 minus 0.5 times 1, which is equal to 2.5, okay, right? Okay, so we can find y1. Okay, what is y1? y0 here equal to 1. So 1 plus h here we use 0.2. So 0.2 times ft0 y0, which is 2.5. Okay. So once you calculate this, they will give you 1.5. Okay, we'll find y1. Remember what we want to find? We want to find this. Okay. So it's 1.5 is what we're looking for. Remember, y1 give you approximation of y evaluate at t1. What is our t1 here? t1 is t0 plus h. t0 is 0, so plus that give you 0.2. Okay. So that's exactly what we're looking for. So we stop here. Remember what is the... Not here, sorry. So what is the y evaluated at 0.2? We will calculate that before. It's 1.43711. Okay. So we got approximation. This is true value and the 1.5 is closed. Okay. Now let's do that again. This time we let h equal to 0.1. Okay. Okay. So what is the t1 here? t0 plus h, which is 0 plus 0.1, so give you 0.1. Let's find y1. y1 equal to y0 plus h ft0 y0. Okay. What is y0? Same as before, right? 1 plus, this time h is not 0.2 anymore, it's 0.1. ft0 y0 is the same, times 2.5. Okay. So, they give us 1.25. You got a number, but we need to know what this number means. Okay. As we said, this number is y1. y1 give you approximation of y evaluated at t1. This time t1 is different than before, right? What is t1 here? It's a 0.1. What do we want to find? We want to find this one. Okay. So we cannot stop. We need to keep going. Okay. So we need to find y2. So y2, what is y2? y2 give you approximation of your y evaluated at t2. What is t2? t1 plus h. t1 is a 0.1 plus h is a 0.1, give you 0.2. Okay. So we can find y2. y2 is y1 plus h f t1 y1. Okay. Use the Eulers formula, let n equal to 1. Okay. So first of all, let's find what is ft1 y1. Again, in this formula, wherever you see t replaced by t1, t1 is here, is 0.1. Wherever you see y replaced by y1, okay. What is y1? Here, times 1.25. You calculate that, you got 2.175. Okay, now we can find y2. Okay. y2 equal to y1. y1 here again, 1.25 plus h is 0.1. Okay. h here is 0.1 times ft1 y1, we just calculated, give you 2.175. Okay, after you calculate that, they give you 1.4675. Okay. Compare with our first approximation here. Wait. Compare our first one. Here. 1.5, right? y1. Okay. We'll find y2. What is y2? y2 give you approximation of y evaluated at t2. What is the t2 here? 0.2. Okay. So that's the approximation we got. Okay. It's closer to the true solution here, 1.43. Right? The first one got a 1.5. As you can tell, the h is smaller. Your approximation will get better. Okay. However, you have to do more computation. Okay. For example, if you will let h equal to 0.01, we still want to find the same thing. We want to approximate y evaluated 0.2 equal to what? So if you want to use Eulers method to find this one, then think about that. How many steps do we need to go? Okay. Here is 0. Say here's a 0.2. Say here's a 0.1. Then this is a 0.01. So you need to go you need to go 20 steps. So you need to find a y1. y1 give you approximation. Give you approximation at y evaluated t1. This time, t1 is 0 plus 0.01. Okay. Like that. Okay. So you need to use Eulers method to find y1, y2 to y20. Finally, give you approximation of y evaluate 0.2. So you spend a lot of time do the computation. Of course, you let the computer do it. Write a simple code, okay? And you can imagine this time, this y20 will give you much better approximation to this true solution. Okay, let me summarize what we're doing here. So, if I've been given a differential equation, we don't know how to solve them exactly. Then we need to solve them approximately, or say numerically. So to solve them numerically, Eulers method is one of the methods. Okay. To use the Eulers method, you need to find h. Okay. So you can generate a bunch of, you can generate y1, y2, y3. You need to know what the meaning of those. Okay. For example, if you want to find y evaluated 0.2 for different h, then this approximation associated with a different y. For example, the first one, y1, would give you what you need. For the second case, h equal to 0.1, then you need to go to 2 steps. If h equal to 0.01, you need to find y1, y2 to the y20.